Woohoo! Welcome back. Tonight we're going to be talking about hyperbolas. Yay! And my elliptical friend Spider is here with us because he was already here and agreed to come deal with hyperbolas. Hyperbolas look a little bit like spider webs, so hopefully he'll feel right at home. So this is the last of the conic sections we're going to study in this chapter. And hopefully, as you take a look at the formulas, you'll see one great big difference. And that is right in the middle, we've got a minus sign. And this is what differentiates hyperbolas from ellipses and circles, because ellipses and circles, the x squared and the y squared terms are separated by a plus. This one has x squared over a squared minus y squared over b squared equals 1. Now, in terms of the details, I've written up all the formulas, and there's a lot of new stuff. You've got vertices, but you also have asymptotes, and there's a box, whatever the box is, and then there are transverse axes. That's very exciting. So there's an axis, but now it's called a transverse axis. And we also have horizontal, shifted horizontal, and vertical, and shifted vertical. And so rather than going through all the details, I thought, why don't we just go ahead and do one? Woohoo! Straight off the bat, let's just try one. Now, how can you tell this is a hyperbola? You might not notice at first, but certainly, as you're sitting down to graph this, what makes this one an interesting problem? So the first thing that I notice is that I do have the x squared and the y squared, and everything is positive, so that makes me think it's an ellipse, except, dum dum dum, the x and the y are on the opposite sides of the equation. So when you're dealing with conic sections, if there's an x squared and a y squared, get them on the same side of the equation. So I'm going to go ahead and move the 4y squared. So I'm going to subtract 4y squared from both sides, and then I get 9x squared minus 4y squared equals 36. And this is what tells me, aha, that is the moment that I say, aha, this is a hyperbola. Next step is, now that I've got a hyperbola, both with ellipses and with hyperbolas, you generally want to divide out this 36. It's going to make it easiest. So I'm going to create a 1 over here by dividing everyone by 36. So I get x squared over 4 minus y squared over 9 equals 1. Now, the thing that is really great about hyperbolas that's very similar to an ellipse is that a lot of the basic construction of this graph is going to look just like the basic construction of an ellipse. So, for example, I'm going to be interested in figuring out what 4 equals. 4 is 2 squared. And I'm going to have to figure out what 9 equals. That's 3 squared. So that's going to look and feel a lot like an ellipse. The difference is this minus. Now, the plus, if it were an ellipse, the plus in the middle keeps everything contained, so that as x gets bigger, y gets smaller, and vice versa. The minus here, the fact that this is a constant difference, means that this is actually going to break out. Since they can be anything as long as one of them is 1 smaller than the other, then x can get as big as it wants and y chases it. So here we're going to have a graph that, rather than staying contained in a nice little football shape, this is going to go whee off to infinity and beyond. So what does that look like? Well, what we're going to do is we're going to start with, again, exactly the way that we would graph the ellipse. And I'm going to throw caution to the wind, see if I can do a decent job of this without graph paper. If not, we'll switch to the graph paper. So x squared is over 2 squared. So I'm interested in moving out 2 units left and right. There's -2, there's 2. And then the y squared is over 3 squared. So I'm going to move up 3 and down 3. Now, normally what we would do is we would go ahead and we would draw, if this were an ellipse, we draw this, right? We draw all these together. But in this case, we're not going to do that. We're actually going to use these points and we're going to draw what I refer to as the box. A lot of people refer to it as the box. It is a rectangular box. Now, that box would contain the ellipse. So if there were an ellipse, and we'll talk about what that means, I'll draw a picture of that next. But this box is going to help us draw the hyperbola. And what we're going to do is, I'm going to bring out my handy dandy ruler. We're going to draw a line that goes through there, dotted line there. And I'm going to draw another one that goes through here. And these are actually asymptotes. Now, you'll see that they go through the point 0, 0. This is centered at 0, 0, which makes it nice. And here is the point. This is 2 in the x direction and 3 in the y. So this is 2/3. Now here, this point right down here, this is 2, -3. This point right there is -2, -3. And this point up here is -2, +3. Okay, those are the 4 points at the corners of my rectangle, this box that I draw. These asymptotes, as long as this is centered around the origin, as long as it's 0, 0, they have a really nice formula. This, the equation of this line right here, is going to be y equals, and you take the y value over the x value. So 3/2 x. That's it. It's that simple. If this had been 2 other numbers, you just put them in there. And then over here, this will be y is -3/2 x. And these are in, I've got the asymptote formula there. So even if you forget it, you've got your formula sheets. Now let's look. Now with an ellipse basically, right, it gets long. Whoever's the biggest number, so 9, this would be, you know, a one like this. This would be an ellipse that's the shower style, right? Longer in the y direction because y is over the larger number. Now here, we're less interested in which one's bigger and which one's smaller. We're more interested in which one is the positive one. The x squared is the one that's the positive term, and then the y squared is the one that's being subtracted. This means that your hyperbola is in the x direction. So here we've got these 2 points. This point is 2, 0. This point is -2, 0. And I'm going to start here and draw a graph that looks like this. And then another piece of this graph that looks like this. And this graph is going to follow the asymptotes. So if you imagine you've got these 2 x's, or these 2 lines that form an x, and then you've got a box kind of in the middle. Hyperbola goes like this and like that, like this and like that. And that's what happens when the x squared comes first, when it's the positive. Now, what does it look like when the y squared comes first? If the y squared comes first, then you've got this top and bottom. So what am I talking about? So now that this is our basic hyperbola, that's the sketch. Woohoo! There are some other interesting things we can look at. This is a horizontal, this one is horizontal, the x squared comes first. There are foci. Notice the foci are different, a squared plus b squared, right? A little bit different. Because the thing is where does the focus need to be? The focus should be how this the shape will curve around the focus. So the focus shouldn't be over here. It actually has to be over here. So the focus here would be, in our case, c squared equals a squared plus b squared. So that's going to be 4 plus 9, which is 13. So our c is equal to the square root of 13. Now, the square root of 13 is, it's somewhere between 3 and 4. The square root of 13 is 3.6 approximately. And so our focus would be right there-ish, probably a little bit closer in there. Radical 13, comma 0. And then we'd go 1 more point and a half. And we'd have this at negative radical 13, 0. So we can work out things like the focus. We can work out different pieces. The center, it's got a focus on each side. These are the vertices right there. It's at x equals 2 and x equals negative 2. Here are the asymptotes, right? Those two diagonal lines. There's a box. There's a transverse axis. So what is that? It says y equals 0, the x-axis. What does that mean? That means that for this x-shaped, right, as it goes off to the left and the right, the transverse axis, the axis that goes right through the middle, is going to be the y-axis. Or sorry, the x-axis. Woof. Y equals 0. Sorry about that. So let's talk about hyperbolas and ellipses and why I think they're one big happy family. So what I'm going to do is I'm going to try to draw this very, very carefully. Let us see. This is x and this is y. So let's see, I'm going to go 1, 2, 3, 4 in the y direction. 1, 2, 3, 4, negative 4. And I'm going to go out 3 in the x direction. 1, 2, 3. Okay, so here's 3. This is negative 3. This is 4. This is negative 4. And I'm going to go ahead and draw this box. And the first thing I'm going to draw is in blue, I'm going to draw an ellipse. And again, I apologize, genetic mutation on my part means I am incapable of drawing an ellipse. So the ellipse, let me scooch this up a little bit so you'll be able to see it. The ellipse looks like this, and this would be x squared over 9, because it goes to 3 and negative 3, plus y squared over 16 equals 1. So that's the ellipse, and that's in blue. Okay. This is the different members of the conic section family. Next up, I'm going to do in orange. I'm going to do the horizontal hyperbola. That's going to be x squared over 9 minus y squared over 16 equals 1. And I'm going to have to draw in my asymptotes. Get those in. This would be y equals, remember it depends on this point. This is 3, 4. So y equals 4/3 x. This is going to be y equals negative 4/3 x. Okay. And the horizontal hyperbola is going to be right here, looking a little bit like this, curving in towards those asymptotes. Okay, so that's the horizontal hyperbola. And then there's also a vertical. I'll do that one in purple. And how is that related? That one is going to be the one that happens that if you have y squared over 16 minus x squared over 9 equals 1. So the y squared is the one that comes first and is positive. Then you've got a hyperbola that comes down like this and up like this. Okay. So it's kind of a pretty family. Now, where does the parabola sit in this? It doesn't easily, because remember that parabolas have not an x squared and a y squared, but just an x or just a y, right? So either it's an x with a y squared or an x squared with a y. So one of them isn't squared. However, could we have a circle? Yes. So do I have a green? Let's see if that will... Ooh, that one won't be that different, but let's see if we can do it. The circle that would be related, and there could be a couple of them, but the one that I'm thinking of, I'm going to make smaller. This would be x squared over 9 plus y squared over 9 equals 1, or x squared plus y squared equals 9. Okay, and what's that going to look like? Well, that's going to be the circle. That is what happens. Oh my goodness. Seriously, I'm a menace. I am a menace. The circle is what happens when either the denominators are equal or you have the coefficients are equal. If you've got the same number underneath x and y, then it becomes a very sad looking circle. I do not know. I would say that when I was young, a witch cursed me. This person will never be able to draw curves in 2 dimensions. Wahahaha. Okay. So, but this is the family of related graphs, and this is how they interrelate. They all kind of sit there with each other. So if you draw the ellipse, you can imagine both the horizontal hyperbola and the vertical hyperbola. You can also imagine if you shrank the y down so it matched the x, if that box was a square, then you could have a circle in the middle. So they're all going to sit together, except for, of course, the parabolas, which they're fine on their own. They do their own thing. They probably, there's probably like a winter holiday party or a New Year's party or something. I'm sure they're all good friends. But that's it. Those are the conic sections. Again, I would encourage you to hold on to these details. Yes, you're going to be able to use them in doing your homework, but also they're going to be helpful later on, because these shapes are going to come back in and haunt you a little bit in calculus. So, good luck. Hopefully this all made sense. If anything didn't make sense, please ask me questions. Please find tutors. We would love to help. And, ask lots of questions and know that we're here to help you succeed. I hope you have a great morning, day, afternoon, evening, nighttime. I hope you get lots of yummy snacks and something delicious to drink, and that you all have very sweet dreams, because you've done amazing work here. Woohoo, and math on.